Hello. I'd like to do just a few things on the periodic table. This is just a very, very basic presentation on just some factors about the periodic table. Before I go too far, I just want to give a little bit of credit here. This table and this picture are both from the Wikipedia, and I believe they're public source, and I'm okay using them. All my videos, generally, I've been doing that because they seem to be public sources. But the credit, there's always been a little bit of debate here and there. There's some people named Newlands and some others that came up with some things that kind of predated this periodic table. But a gentleman named Dmitry Mendeleev, and this is his picture here, we give him credit for the development of our modern periodic table in 1869, primarily because he used it to predict some undiscovered elements at the time. And again, in science, one of the best things about a theory is its ability to predict unknown things. And he was actually able to predict some things. For instance, germanium was an unknown element at the time, and based on his arrangement, he felt that there was an element that needed to be discovered. Silicon was known about, tin was known about, but there was this element that there seemed to be a gap as he was arranging his original elements, and so he predicted that an element would be discovered. Obviously, germanium ultimately became the element and its name. But he was also very accurately able to predict the properties of germanium by looking, and this is something we'll talk about here, is you go up and down a column, we call them groups or families in a periodic table, they have very, very similar properties because they all have the same number of outer electrons, so they behave in a similar fashion. But as these atoms get bigger or smaller going up or down, there are certain properties that tend to increase or decrease as well. So he basically looked at the properties of silicon and tin and kind of averaged them together and predicted a lot of the properties based on the valence electrons, the behavior, the bonding behavior, and so forth, the germanium. So that was his true thing. He actually predicted 4 elements, scandium, gallium, technetium, and germanium, and he predicted their properties very well. So he is generally given the credit for the development of the modern periodic table, although there are certainly others that recognize some of the periodic trends. Now what he did is he arranged the elements by mass. Modern tables are actually arranged by atomic number, which is this number you see here, and that is the number of protons, and I'm just going to abbreviate that with a P plus, in the nucleus of the atom. That wasn't really figured out until the early 1900s, and for that reason, this was not known about because, again, this was published in 1869. But what ended up happening is he arranged them by mass. And by and large, that worked with the exception, just a few elements he had to rearrange based on their properties. But everything else, it worked perfectly. So he arranged them by mass, and as he did so, he went along and he found the properties repeated at regular intervals. So, he'd be looking at lithium and beryllium, boron, carbon, nitrogen, oxygen, fluorine. I don't believe the noble gases were known about at the time, but the next element was sodium. And he recognized the similarity of sodium to lithium, and so he started a new row, and he arranged them along this kind of a pattern, and again, recognizing certain gaps that, maybe the next element in the sequence didn't fit, so he'd leave a gap and then predict the property. So that's a little bit on the origin of the basic periodic table. And as I said, eventually in the early 1900s, a guy named Moseley came up with a way of counting the number of protons in the nucleus, and then our modern table, of course, is arranged by actually the atomic number. So the original periodic law by Mendeleev said that the elements, when arranged by their atomic mass, have a repeating or periodic properties. The modern law just says when arranged by atomic number, which again is the number of protons in the nucleus. Now, a couple of things I want you to know. Number one, we have what we call groups or families, which are the vertical arrangements. So as you go up or down, we're going to call that a group or a family. And they are numbered just sequentially, 1, 2, 3, 4, 5, 6, 7, all the way over, and then this will be 18. We also have what we call periods, and they are numbered 1, 2, 3, 4, 5, 6, and 7. And again, these are known as periods. Now, what about these guys down here? These, the lanthanides, actually belong right here, and the actinides, these guys here, actually belong right in this row. So you would actually, and you can see the numbering, 56, 57 comes down here, that's 71, and then it continues. These are put down here generally out of convenience so that the periodic table is not really, really wide, but if you to actually do it the way you're supposed to, you would actually cut it and then insert these elements. So these are called the lanthanides for lanthanum, which is the first element here, and these are called the actinides for actinium, which is this lower row. So you've got your groups or families, you've got your periods. There are 7 periods. Periods 6 and 7 include these two guys at the bottom. A couple of very common family names you should know. Group 1 is also known as the alkali metals, and that does not include hydrogen. Hydrogen is generally not considered an alkali metal, or at least I'm not going to treat it that way. Group 2 is known as the alkaline earth metals. Group 17 is the halogens. And many of you know that column 18 is known as the noble gases. Sometimes just called the inert gases, noble inert gases. There are some other names. This group would be the chalcogens. This is column 16, 17. Sometimes they're just called the group 16 elements or the group 15 elements. Sometimes they'd be called the oxygen family or the nitrogen family. So there are some other names out there. Now, some other things you should recognize is there is a stair-step line that begins between boron and aluminum and kind of goes down through, and these separate out the metals from the non-metals in the periodic table. Things this way on the periodic table are considered to be metals, and you can see that's going to include everything. That's going to include all these guys, the ones down here. Things to the upper right are considered non-metals, and that would include your hydrogen, which in some ways actually belongs here because it's 1 electron away from a full shell. Along that stair-step line you have elements that have properties of both metals and nonmetals, and they are called the semi-metals or metalloids. Your nonmetals tend to be dull in appearance or brittle if they're solid, generally non-conductors of heat, non-conductors of electricity, don't react very vigorously with acids, things of this nature. Metals are kind of all the opposite. They tend to be shinier, they tend to be malleable, ductile, conduct heat, conduct electricity, react with acids, and so forth. These semi-metals or metalloids along this stair-step line kind of have properties of both. Some of them you'll find are shiny, but they're brittle, and they conduct, but they're brittle, or what have you. So you have properties of both. So that's the metals and nonmetals. Now, a couple other things. Sometimes groups 1 and 2 and groups, this is group 13 and 14, groups 1 and 2 and 13 through 18 are known as the main group elements, which I'll usually sometimes refer to them as. Groups 3 through 12 down here are oftentimes referred to as the transition elements or transition metals, and your lanthanides and actinides down here are sometimes known as your inner transition metals. Transition metals. A lot of writing there. Those are your inner transition metals. Sometimes they're just called the lanthanides and actinides at the bottom. So that's just a kind of a quick tour of the periodic table. A couple of the very common group names, what a group is, what a period is, and then some of the larger classifications of the elements.